Hello guys, welcome back. In the last video we had been discussing about decision statements in C, and in this video we will discuss about iterative statements in C, that means loops in C basically. So the two topics that we will discuss are types of loop and loop termination. Now first of all, let us take a look at types of loop. So C essentially supports basically three types of loops, that is the for loop, while loop and do while loop. The functionality of all the three loops is more or less the same. They perform the same task, but just there are a few tweaks here or there. So first of all, let's discuss about for loop. So for loop, as it is already written over here, for loop is an entry controlled loop. What that means is, for any loop there are actually three elements: the initialization, the condition checking, and the increment or decrement, basically the loop counter. So in case of for loop, in entry control, so this means that the loop is the condition checking of the loop is done at the beginning of the loop. That means as soon as the loop starts. For example, say you want to iterate over or say you want to print 10 numbers. So in order to do that, we will run a loop starting from 0 or 1 until 10. So the condition checking of the counter will be done right at the beginning of the loop, and the condition checking will be such that it will check whether my counter value is less than or equal to 10. If it is less than 10, then obviously the loop will continue, else it will terminate. So that is the condition which needs to be checked in the loop. Now if there is no condition checking, the loop will become an infinite loop. The loop will never stop. Okay. So the next type of loop is while loop. This is also entry controlled loop. There is just a basic difference that we will see over here when we code. You'll get that. And the third type of loop is the do while loop, which is an exit controlled loop. So exit controlled loop means the condition checking is done right at the end. So the advantage or the difference between an entry controlled loop and an exit controlled loop is that entry controlled loop will run if and only if the condition is satisfied. That means if the condition fails for the first time, the loop will not get executed even once. But in case of a do while loop or an exit control loop, whatever the condition may be, the loop will run at least once. That is, even if the condition statement is false, the loop will obviously run once because the condition checking is done right at the end of the loop. Now we have loop termination. So loops are of two types, obviously finite loops and infinite loops. So finite loops are those obviously which terminate after a certain amount of time or after executing for a certain amount of time, and infinite loops are those which never end. Okay, so that is more or less what we will be discussing in this video. So let us get started with the code. So first of all, I'll illustrate to you the for loop. So hash include stdio.h, which is our kind of a regular formality that we have to perform, and we write return 0. Now for any loop we need a counter. So let us say our counter is int I, and say suppose we want to print numbers from 1 to 10. So first of all we will write I is equal to 0, I less than 10, I plus plus. I'm giving us a very simple example right now. We will see some complex ones later on. So printf %d, I. So you see what we have done is, this is a basic for loop which has been designed so as to print 10 numbers starting from 0 and ending at 9. Okay, so what I've done is I've written this for, which is obviously a keyword over here. For is a keyword. Then I have this I is equal to 0, which is the initialization part of the loop. As I've already told you, every loop has three parts. The first one is initialization, second part is condition check, and the last one is increment increment or decrement. So these are the three essential parts of any loop. Obviously you can skip this one as well as this one, but then if we want to design a normal loop, then these are the three important parts. So I is equal to 0 does the initialization, I less than 10 does the condition checking, and I plus plus does the increment or decrement. Obviously I am incrementing I. Why? Because I am starting the value of I from 0 and I want to continue till 10. So in that case, obviously I have to increment the counter. If I decrement it, then the loop will run in a reverse direction, which would obviously lead to an infinite loop, and we don't want to do that. Now what I've done is, see, inside this for loop, I have written a printf statement. Over here, what you need to note is that because I have only one printf or only one statement after this for, I can ignore putting the brace. But if you have multiple statements, then just like if statements, over here also you have to put this brace. Okay. So okay, let's leave the brace as it is. So this is the syntax for a for loop. So let us save our code, and then we shall see whether it runs perfectly or not. So let's say the name of the file is maybe loops1, and it is my C file. So loops1.c. Save. So if we expect the output, okay, let's say I put a /n over here so that the code is readable. Okay, or maybe /d. Now if we compile, if there are no mistakes in the code, then obviously we will see on a single line values starting from 0 to 9. Let the code get compiled. Okay, so over here, as we can see, the first value is 0, 1, then is 1, 2, 3, 4, and so on until 9. So that is what we expected. Now, what I said was we can skip this condition. If we do that, what happens is the loop will run probably infinitely. See, this has turned out to be an infinite loop. Okay, so that is the process how you make an infinite loop. Control V, oops, Control Z. Next, let us take a look at the syntax for while loop. So let's say we make a new file for that. I'll write while I is less than 10, printf %d /t, I. So this will also do the same thing. Now what you need to note is that the syntax is a little different. Over here what we had is, we had all initialization, condition check, and increment. Everything was at one place. But in case of a while loop, we don't have that. In case of a while loop, you need to first initialize it outside. You need to place the condition check over here, and you need to place the counter obviously, and that is inside the while loop. Let's say this is loops2.c. So for this file for this while loop also, we have three essential parts, that is initialization, condition check, and increment or decrement. So over here this code will also print the values from 0 to 9. Let us run this, or let us compile this first and run it. Now the entry control and exit control thing, see, even the for loop, the condition checking was right at the beginning. Okay, that's the output for the while loop. See, we got the same thing as the output, same like the for loop. Now what I was saying was, in case of a for loop, we had the condition check right at the beginning. In case of while loop also, we have the condition check right at the beginning. But next loop that we will see, that is the for do while loop. In that loop you will see that the condition check is right at the end, unlike for and while. So let us copy the same code. Over here also, you need to specify the initialization first. and the syntax is like this: while I is less than 10. Okay, so let us save it as loops3.c and build it. And yes, one more thing that you would like to notice is that I have placed this semicolon over here. If you don't place the semicolon in case of a do while loop, then that would show as an error. Why that happens is because, see, in case of a while loop, we had this while statement, or the statement containing the while thing. Then we opened a brace, and over here we closed it. So obviously, if I terminate this one with a semicolon, it means that I have terminated this part of my code over here itself. So it will essentially never get inside this pair of braces. Okay, so this code will remain unexecuted. Why? Because this was supposed to be a part of the while loop, but because I have terminated the loop over here by providing a semicolon, it will never ever enter into the code or into that block. And same goes with the for loop. Over here also we don't place a semicolon, but in case of a do while loop, we have to place a semicolon over here. Why? Because this thing is the last thing in this line. So if you do not place a semicolon, the program does not know, or the compiler does not know, that it has to terminate execution here. Okay, so obviously the output, you can see it is matching. Now say suppose I initialize I with 10. Okay, and over here I have the condition as I less than 10. So obviously this is not true, because the value of I is 10, which is not obviously less than 10. It is rather equal to 10. But even with this condition, you will see that my loop would work at least once. See, and the reason why that happens, you will understand. See, I have got a 10 over here. Now if I do the same thing with while loop, you will see that it will not work. See, we did not get anything in the output. And same goes with the for loop. Now why that happened was, in case of while loop, the condition checking has been done right at the beginning. But in case of do while loop, the condition checking has been done after this set of statements has got executed. Okay, so that is the basic difference between an exit controlled loop, that is a do while loop, and entry controlled loop, that is while and for loops. So that was the basics of loops. Now one more thing that has to be explained is, see, over here you might get confused that I is equal to 0, I is less than 10, and I plus plus. So essentially, but just by seeing it once, you would think that every time this piece of code is executed, the control again goes, or control again shifts over here. So I must get again initialized with 0. But that actually does not happen. Why it is so? The reason is that this initialization part is always done only once. Even though it is written over here, but that initialization will be performed only for the first time when the compiler enters, or when the compiler encounters this for, and for the subsequent times this will be not considered. But yes, this condition checking and the increment or decrement, whatever it is, that has to be done every time. Now what is the order? So the order is that first initialization will be done, then the condition checking will be done. After that, whatever you have written inside this for block, that part will be executed. That means body of the loop is executed, and after the execution of this body, the counter is incremented. It is not that the counter is incremented right after execution. Why? Because see, when I run the code, what you would notice is that the first value that was printed was a 0. See, the first value that is printed over here is a 0. It is not actually 1. Now, if the counter were incremented before this part is executed, what would happen is the first value that we would get would have been 1. Unlike in this case, we have got a 0 over here. So that shows that first the block of for is executed, and once this execution is done, the counter is incremented. So the loop goes something like this: first initialization, then condition check, then the body is executed, Then comes the increment or decrement. Again, condition check, body is executed, increment, decrement, condition check, and so on and so forth. So that was the basics of loops. Now, using this loop, say suppose we want to print say using any loop we want to print the multiplication state or multiplication tables. Okay, so let's write hash include stdio.h. okay, I can actually just copy this entire thing. Say we want to print the multiplication table of 5 and let us use a simpler loop, that is while loop. We can get rid of all this thing. So int num is equal to 5 comma I is equal to 0. Now while I is less than, okay, let's say I is 1, while I is less than equal, when I is, okay, print f, let's say num, okay, percentage d. So we have num comma space multiplied by percentage d. Okay, so we have 5 multiplied by whatever the value of I is equal to percentage d comma num into I. So that is what we have to print. Now once this printing is done, let's say we want to give a new line, say table, table, let's it be a C file, save it. Okay, probably the code is fine. So if it does not show up any error, then the code must print the multiplication table of 5, and that is actually so. So see what happened. 5 into 1 is equal to 5, 5 into 2 is 10, 15, 20, 25 and so on until 5 tens are 50. So what happened over here is, see, I have given num is equal to 5 and I is equal to 1. So the loop, the initialization of loop has been set to 1. So the loop will begin with 1, and for the first time, okay, see, what we have is, for the first time, this is the value of I. That means when the entry to this loop is made, obviously the condition is true because I is obviously less than equal to 10. So no problems with this. When the control shifts inside this printf statement, we have percentage d, that is num, it's 5 into I. So this percentage d corresponds to I, value of which is initially 1. So that is why the 1 has got printed over here. And then we have num into I, that is 5 into 1. So 5 into 1s are obviously 5. So that has got printed. Now after this thing is printed, the value of I is incremented by 1. I plus plus means I plus plus is basically I is equal to I plus 1. I plus plus is equivalent to I is equal to I plus 1. Okay, so the increment has been done. Once this increment is done, the control again shifts to the beginning. The condition checking is done. That means 2 is obviously less than equal to 10. So the control again shifts over here. And we get 5 into 2 is equal to 10. So that is what actually gets carried on until the value of I becomes 10. So when the value of I is 10, again you see this condition gets satisfied because 10 is obviously less than or equal to. So the second part, that is equal to clause, gets satisfied. So 10 is equal to 10. This printf will be executed. I is again incremented to 11. Now when the condition checking will be done, 11 is less than equal to 10. Obviously that is false. So the body of this while is not executed. So it will be skipped, and then the control shifts to return 0, and hence the program ends. So that was a multiplication table. Okay. Now Few programs that I would suggest you to try is number one, try out factorial. So in case of factorial, what happens is, suppose you want to calculate factorial of 5. So that would mean 5 into 4 into 3 into 2 into 1. Okay, make sure you do not place a into 0 over here, because if you place a into 0, the entire factorial would turn out to be 0. So the logic I shall give you, the logic is that first you have to maintain one variable where you would store the result. Say the variable is fact, and you have to initialize this variable with something, say 1. Now what you will do is you will start a loop and you take an input from the user. Okay, say the user gives an input to calculate the factorial of 5. So the loop will run 5 times. Now it is up to you whether you would start it from 5 and end at 1, or whether you start at 1 and at 5. It's basically the same thing. The answer is going to be the same. Okay, so what you'll do is your assignment statement would be like fact is equal to fact into I. So this would be your assignment statement. Now if you start off, then make sure you either start with 1 or you start with 5. If you start with 1, you have to increment the loop until the value of that number is reached, and if you start with 5, then you have to obviously decrement the loop until 1 is reached. But make sure that you do not go until 0, because that would again change the entire answer to be 0, which is meaningless. Okay, so that is the logic for factorial of a program. Another program that I would suggest you to try is the Fibonacci series. Now what happens in a Fibonacci series is, it is actually a series in which, okay, let me see, Fibonacci, okay, 0, then we have 1, then 1, 2, 3, then 5, 8, 13, then we have 21, and so on and so forth, maybe 34. So actually this series would keep on going. So the next number, if you can guess, what should be the next number? Well, the next number would be 34 plus 21, which is 55. 55. So what's the logic? The logic is that the first number is always 0, second number is always 1, but thereafter this 1 is equal to the sum of the previous two numbers. That means 1 is equal to 0 plus 1, this 2 is equal to 1 plus 1, this 3 is equal to 1 plus 2, 5 is equal to 2 plus 3, 8 is equal to 3 plus 5, 13 is equal to 5 plus 8, 21 is equal to 8 plus 13, and so on. So one number is the sum of previous two numbers. So this also you have to implement using any kind of loop. It can be using for, while, or do while loop, but the first two numbers you have to print using hard coding technique. That means you have to print 0 or 1 over here. Okay, so and after that you have to increment your loop, and the value to be printed would be the sum of previous two values. So try this program yourself, and that would actually give you a very good revision of the loops concept. Okay, so that is probably all for this video. Thank you. Actually, yeah, one more program that you can try out is to take a number as input from the user. Take a number as input from user and print the tables until that number. That means, suppose the user enters, say num is equal to 10. Then what your program will do is, your program will print the tables of all the numbers until 10. That means you have to print the table of 2, 3, 4, 5 until 10. So this would be your program. In this case, you have to use the concept of nested loops. This is a concept which I did not discuss, actually I forgot it. See, what happens is, just like in if else, you have nested if, nested else, and so on. In case of loops also you can have nested loops. For example, you can obviously write this, say for I is equal to 0, I less than 10, I plus plus. Inside this loop, you can always write, say j is equal to 0, j less than, say 10, j plus plus, and then maybe there should be a printf, say percentage d comma, maybe I plus j. Okay, I plus j. Okay, let's write a slash t here and printf a slash n over here. Now see, over here what I have done, okay, let's declare variable j. Over here what I have done is, see, there is one outer for loop, and inside this loop there is one more loop, that is this one, and inside the body of this loop we have a single printf statement. That's the reason why I did not include a braces, but if you want you can always have braces at the end. Okay, now so this printf statement basically corresponds to this for loop, and this one, this statement, this printf statement corresponds to this for loop. Okay, so basically we have a nesting of loops. This nesting can be done until any level, but we generally use a 2-level nesting, because that level of nesting, that 3-level, 4-level and so on, that is not really very useful. But this 2-level nesting is very useful in case of arrays. When we will study multi-dimensional arrays, or 2-dimensional arrays to be specific, we'll be using a nested loop. So this concept is going to be very useful later on, and even when you practice further programs, you would realize that this is very important concept. Okay, now one more kind of programs that I would suggest you to do is pattern printing programs. For example, print the following pattern. Say pattern is, say suppose you have a star over here. Okay, then maybe you have, say, a star. Basically the idea is to print a triangle of stars or asterisks. So you have a star here, so there must be a pattern basically. What do we have? Okay, so there will be one star here as well, then a space, star, star, star. So see, this is obviously a pattern. In the first line you have 1 star, second line you have 2 stars, third line 3 stars, fourth line 4 stars, and here are 1 space, 2 space, 3 space. So this is a logic. This is actually, this pattern printing can be a very good tool for you to understand how to code using loops, how to use loops to perfection. So pattern printing is going to be a very important practice. Okay, so you need to print such patterns. Several other patterns could be like, say 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and so on. 1, 2, 3, 4, 5. These kind of patterns also you can print. These patterns seriously will be a very good practice for you to understand the concept of loops in details. So practice these and you would see that loops will be in a very good grip of yours. Okay, so that is all for this video. Thank you.